Swayam Prabha. Digital India. Educated India.
Dear students, we are in the module 6 of the course Fire Safety in Buildings. So far we have understood the various systems which can save the building from fire, what we need to do. We have understood the passive methods, we have understood the active methods, the sprinkler system, the riser system, which are all integral part of the building. But the safety of the occupants or the people who are inside the building comes at the very first point. So, my building is equipped with everything. Yes, the people will be helping the system to work, but the evacuation becomes very important because the precious or the most costly are the human lives. Appropriate signages can help or direct people from one place to the place of fire to a place of safety. We have already understood the various processes of compartmentation, how to control fire within a space, and we have to understand the evacuation at all times are dependent on who the people are. If it is a hospital, the patient cannot come out on his or her own. Those who can come can behave normally, can come out normally, but there may be people who are immobile. So, there are different principles for different buildings which we will later on explore. However, the main people who are main or the basic is the staircase and the corridors are the points through which people can come out. There are certain buildings like a residence, every day you stay in that home, you know where is the door, where is the window, where from I can go out of the building, even if in case of extreme necessary I can jump out of the building from a balcony or a veranda. So, it is very important that how you are oriented to a building. You go to a shopping mall, you have no idea or no clue what is there, where from to come out. It is all fun, it was all fun for you, and suddenly it becomes you are in the dark and you cannot find out your way from the building. So, we have to understand the principles and what are to be there in a basic building. So, the means of escape are the ways through which one can come out, travel out from any point of a building or a structure to a comparatively safer place. So, it should be a continuous path. So, suddenly coming down from a staircase, it is blocked and you have to take another route and go and carry through another staircase further down is not desired to be a good design. So, the exit access, exit path, exit discharge are the three components. With that, so when we see, as you all are in the higher stages of being an architect or already you are in a profession, what is there? You all follow the bylaws. The staircase width is this 1.2 meters, staircase width for a general residence 0.9 meters, for an institutional with so many 1.2 minimum. So, what is there? That is our path of access. Corridor width for institutions it is 2.4, sometimes it is 2.2. So, all those corridor widths, these are to allow people in full to move out from the floor, because these are all connected to one floor. Say a corridor connects a floor, whereas a staircase connects the building floors. So, what is there? So, if I say this is my floor plan, this is my floor plan, this is my floor plan. So, the corridors will connect, corridors will connect, corridors will connect you to one staircase which is here. So, you can get connected to this staircase. So, all the occupants in this floor plus this floor plus this floor will come to this staircase and get rescued. So, comes the second important point, which is occupant load, which is that number of people a particular floor or area of a building can hold. So, it is per floor. So, the occupant load of the building will be summation of all the occupants of each floor together. So, occupant load factor, what is that? Floor area in meter square per person. Floor area in meter square per person dedicated. So, for an assembly building, my occupant load factor is 0.65, means 0.65 given, and my floor area is given as say 1000 meter square. So, my occupant load will be 1000 divided by my occupant load factor, which is 0.65, and my total occupant will be 1539. So, when we are planning for saving these people, we have to plan for these corridors that can take a proportion of this, which is the building's individual floor population, and then they are to be rescued through this staircase. So, that helps in finding what should be my width. We will go to that later. So, the planning and designing the means of egress is also dependent on. So, it is dependent on the occupant load. Other than that, occupants' reaction during emergencies. Not all people will react in the same way, because there is a fire. They may think, let me take my belongings and go. Let me take my valuables and go. Let me take my medicines and go. It depends with various ages, types of, it is human behavior, it is a very subjective method. Then capacities of the means of egress, as I told, if my design is not proper, the capacities of my means of egress can lead to choking of my corridor. Then comes my anthropometric factors, because people's mobility, people's self dimensions, people's reaction times, these are all the anthropometric factors. Flow of people in opposite direction. So, people may be coming from one side of the corridor or other coming from the other side of the corridor, because people are all in a panicked situation and they want to come out. So, other than this occupancy load, so occupancy load is the objective parameter which you can measure and you can control by putting wider staircase or putting wider corridor, because you have to accommodate that load. However, the anthropometric parameters, the reaction times, etc., the flow directions, they can be hindering the process or delaying the process of exit. So, now if you can recall from the first module how a fire grows. It is the starting time, the incipient time, then starts the ignition or the burning, and within a very small time it reaches its flashover, and then it is fully developed fire, after which the decay starts. Now, in this axis is time, which is the clue by what time the building needs to be made safe or needs to be evacuated. And on this axis you see the temperature. So, we cannot afford to have very high temperature reach, because then the entire people will get into problem. Along with fire, as I have already discussed in my previous modules, in my fourth module, if I am correct, that we have talked at length on smoke. So, even if the fire is not touching you, the heat can affect you, the smoke can affect you. Whom? The people who are in the building, who needs to be rescued. So, we see there are two terms, A set and R set. A set is available safe egress time. Till what time? You see, available just at the point the flashover is happening. And what is the other one? R set, which is required safe egress time. It is available, however, it is better that you are required to leave the building, even the alarm sets and you please go out. So, available time when the flashover is reached and the full fire is set, that is not at all a desired time to get out. So, maximum time is the A set or the available safe egress time, and it is desired that people, whatever is required to get out, which is addition of some time, is the R set time. So, during that time the fire is just developing, the alarm is set and please leave the building. Now, with these two things, what is there? The time is there, and how much is that time? It is usually in minutes, and by that time the entire building has to be evacuated. It is usually within 30 minutes, usually 20 to 30 minutes depending on the scale of the building, etc. It varies. However, this is the tenable limit beyond which nothing can be. It is very difficult to evacuate people, because if the building is having a large fire and it is spreading, then nothing, it is very difficult to take out people. Nothing can be done is not the right word. So, people are, the rescue people enters in. So, what you see, the ignition time, the detection time, the alarm time, the recognition time, the response time, the evacuation time, after which it becomes untenable. Ignition time is that the incipient time. Next is the detection time. You detect the fire, like devices detect the fire, people detect the fire. What happens? The moment it is detected, the alarms, it may be voice alarm, it may be alarm integrated within the building, which is activated. Then is the recognition time, time at which the first fire is recognized by the occupants, because the occupants are to be evacuated. So, this alarm buzzer bells rings the bell in one's mind and people recognize, which is also a small time, recognize that it is fire and we have to evacuate, and they take some response, time at which the situation is responded by the occupants. So, even after recognition they start thinking, oh, I have to leave the building, I am in the middle of the night, I was sleeping, so I have to leave this building. So, this response also takes few minutes, and then he starts evacuating, and it is the entire time which is required, the area is completely evacuated, is the evacuation time, after which the fire produces narcotic gases, irritants, heat, smoke, toxic gases, and it may kill the residents. So, as you see, till untenable condition is there is the available time. However, the evacuation should be done with the required within the required egress time. Some time pre-movement, that means that recognition, alarm and response time, and only a small part is the travel time, where actually the corridors or the staircases, corridors and the staircases are occupied. Hope it is clear to you all. So, these are the basic things which were discussed: the required safe egress time, the available safe egress time. Obviously, the available safe egress time is always greater than the required safe egress time, it should be. If it is less, then there is chances of human loss. Recognition time, reaction time and egress time, where egress time includes the corridors or the staircases to the safe point. Now, coming to further details, what will be this required safe egress time? Time from ignition to detection, time from detection to alarm, time from alarm to when each occupant begins to move out, plus time taken by each occupant to walk through the exit to the escape routes. It is driven by human behavior, speed and pre-movement behavior, and it has to be recalculated because the values change if the air temperature is more than 60 degree. As I told, the heat is gaining, the fire is growing and the heat is gaining, the temperature is rising, and the visibility distance from 5 to 10 meters, and also at 2 meters above the occupant level, what is the visibility distance, which is also important because of the smoke, which forces the speed to approximately 0.3 meters per second. So, why are we again or repeating these things? Because my evacuation time is very important to take each and every people out of the building. Yes, signages. Signages play an important role. Now, in case of fire, it is told that we should not use lifts, but use staircases. But as I had already mentioned in some of my module, that nowadays we have the fire lift mandated by the National Building Code, and yes, for high rise buildings it is becoming an integral part. So, the lift is becoming, but that lift is a special type of lift, and we will further discuss in this lecture. Otherwise, it is the only staircase that is left. You can see there is no light. So, here you see there is no power. Some emergency lights may be there showing the path. Other than that, we can take help of fluorescent signs, so that with some light falling on it, you can get some wayfinding. and outside is the point where you are asked to assemble for rescue or for safety reasons. So, you are asked to assemble, which is a safe location where you are not, where it is expected that the fire will not go and do any harm to any of the inmates. So, we get from here is some emergency light. So, some emergency connections are on, whereas the power of the building is off. We can take help of fluorescent signs to give some indication for the paths for the people. Otherwise, with smoke, the obscurescence is such you may not be finding any of the signages helping you out. There are also evacuation routes displayed on the floors of particularly buildings where people do not go regularly, where people are not oriented to on a regular basis, like a shopping mall, like a hospital, like a hotel. We never go and live in a hotel always. So, we do not know exactly, we are not oriented where is the staircase, through which staircase I should go, which staircase to take. So, if you take 2 minutes time, you can see that at some point or very nearby to a staircase or a lift, these kind of plans are shown, where you can see the human beings are drawn, that this is the rescue path, and some wayfinding signages direct you towards these paths. There may be escalators, etc., because this is a shopping mall photograph taken by me. So, you can see there are escalators which stop, but you can use the staircases, use the static escalator for your escape route. So, the corridors are highlighted, marked, and it is a very complex kind of a plan, but the routes are very simple. From your any point you are here, you have to find out your exit. So, these are the exits, these are the fire exits, these are the fire exit staircases. So, now you can see in this floor plan there are 1, 2, 3, 4, 5, 6, 7 exits. As I told you in my previous lectures, the distance between the two staircases and the dry riser system, wet riser system, which initiates with the operation, those become so important. So, this is a long building and also a wide building which requires so many fire escape staircases. Now, in cases which is not a shopping mall, if we can have partitions in between the mandated space, we can compartment or segment the building into parts. How does it help? It helps like the people do not need to move out who is in the next compartment which is not affected by fire. It may be compartments in horizontal, it may be compartments in the vertical. Who is the barrier between the two? Concrete floor. Concrete floor has a 2-hour fire rating, minimum of 2-hour fire rating is there, because you do not need more than that time to come out of a building. So, compartmentalization can control the movement of fire from one area to other, also can control or restrict the movement of the people from one area to other. So, what happens? The evacuation process can be fastened because if my one compartment is facing fire, the people from that compartment needs to be channelized out, which was not possible for when there is it is a shopping complex where there is a continuous flow of people and movement, and people wants to visit each and every store. You cannot restrict or stop or build a wall or build a door which is built an assembly of a wall and a door which is fire safe, and say this is my shopping mall's zone A, zone B, zone 3. It is not possible. So, you have to give coverage, you have to give visibility to the entire exhibits, entire shop windows. Okay. So, compartmentalization can control also what? The stack effect because of the smoke. So, the smoke does not move from one area to the other. So, doors, windows, ceiling, doors, windows with ceiling of their gaps through which things can that means smoke or fire can move from one place to other is also a way to control the fire and control the evacuation process. It is told that compartment should be 500 meter square as per NBC 2016. So, if you have a area more than 500 meter square, it should be segregated by some fire barrier, and it is 750 meter square if it has a sprinkler system on it. So, see, when we were talking of height of the building in my previous module, here we see we are also talking of the floor area control, because we have a sprinkler system, you get another advantage of 250 meter square, because fire sprinkler system is expected, is an active mechanism which is expected to control the fire at the first point if all other systems are working perfectly with it. Structural stability, as I told, all compartments should be having 2-hour fire rating or having a type 1 construction. In long building, fire segregation or separation shall be at distances not exceeding 40 meters. So, along with the 500 meter square for non sprinkler system design, you also get another, that is 40 meters, not more than, should not be more than 40 meters in length. So, if you have a very long building, you have to plan accordingly. If it is a say hospital, you have your inpatient department, it can be totally segregated out from the outpatient or another part of the hospital building, so that your inpatients are least affected in case of a fire where smoke can also come and disturb them. So, you see glazing specifications, we have also discussed on that, how the glazing and the movement of the smoke away from the building, if it is a smaller orifice, if it is a larger window, it will graze through the building wall. So, these are becoming these become mandatory when you are planning for an evacuation system also. So, we get the concept of compartmentalization here. Now, what does it ensure? As I already told, it ensures air tightness, it ensures discontinuity, it ensures structural integrity, it ensures durability. So, compartmentalization can reduce the evacuation, the load of evacuation, and it can be segmented only to, or it may be confined to only one compartment, and the rest may not be required. Now, as I talk about compartmentalization, you have to understand that you have to seal all parts of the building, because smoke or fire should not be entering from one compartment to other, and this is very important for high rise buildings. So, all vertical shafts, all the rooftops, outside walls, windows, doors, bottom of the building, that is basement if any, isolations from the vents, mechanical rooms, etc., are to be ensured for various types of building, and compartmentalization has to be ensured. Now, let us come to the our focus, which is evacuation. So, what is evacuation? As I told, taking out of the buildings from the people from the building. So, which is the maximum stressed one? It is the staircase, because lifts are no longer operating, and each of the floor, from each of the floor people are coming out. So, if I try to, as I had drawn there, if I try to say that my floors are here and there is a staircase connecting all the floors, what is happening? The people are coming out from the floor to this, and there is a staircase connecting. This is the landing, again staircase connecting, again staircase connecting. So, what is happening? From this floor, my occupant load people are coming out. From here, some more are joining, some more are joining. So, some more are joining. From here again some more are joining. So, what is happening? At this point you get those yellows, blues as well as greens. So, here there were blues and yellows, here there was only blues. So, what is happening? More you are coming down the building, more you are coming down using the floors and the staircase. It is a lot of people creating a crowd. So, from top people were thinking that okay, we are safe, we are running down. Gradually these yellow people joined, gradually the yellow and the green people join. So, it becomes a crowd. So, there are two formulas given for that, or else it can be such that I am the only person here and I need to come out. So, what will happen? I will take this travel path. With my travel speed, there will be a time required. So, what is that T1? T1 is the egress time under congestion. What is Tn? Tn is the egress time during free walk. So, if I am walking free walk, because I have to come out by a given time out of the building. So, this is my exit to an assembly point. So, what is happening? The formula is given n into small n into capital N divided by Fs into W plus Ts. What is Ts? Walking time between adjacent floors, which is free walking. Typically it is 16 seconds if it is a 11 feet high building, 11 to 12 it is 16 seconds. So, if you walk down from your first floor to your ground floor, you will say at a normal speed without any person interrupting you, you will take 16 seconds. What is n? Small n is the number of floors, how many floors you have. What is capital N? Number of people per floor and exit. So, what is the number of people per floor? At exit. At exit. What is the number of people? That occupant load you had calculated, that is the number of people per floor. And then what is Fs? Fs is the nominal occupant flow on the staircase persons per meter per second, which is maximum 3.8 persons per meter per second for jam condition. That means, for crowding condition, jam condition is crowding condition. And what is W? W is the effective width of the staircase. So, if you have a staircase, the effective width of it is, you reduce 0.15 meter from both the sides. So, if my staircase is like this, I have to take out 0.15 meter from its side, because you are not exactly means your counting is done, your body is not touching the wall and coming down. So, you have to keep that clearance. So, with all these, what to do? You have to find out myself coming down at a normal or a nominal speed of of a normal speed of I am coming down, and T1 is the egress time, and then last is the Ts, that is walking time between adjacent floor, and when it is Tn, that is egress time during free walk, it is which is the number of people per floor divided by the nominal occupant flow into the width of the or the effective width of the staircase plus n times Ts. N times Ts is number of floors times the adjacent floor walking time. So, if we go and see one small problem, we can see that for a 50-story building with stair width 2 meters and floor population of 100, effective width of staircase is 2 meters. So, the staircase width means the width of 1, this is 2 meters. So, what is the effective width? 2 meters minus 1.5 0.15 meters into 2, because on two sides of the staircase you are leaving that 0.15. So, the effective width of the staircase is 2 meters minus 0.15 into 2, that is 1.7 meters. So, T1 is, my building is having 50 floors. If you take this formula, T1 is n times n, where n is the number of floors and small n, capital N is the number of occupants per floor. So, that is given as floor population is 100. So, 50 is the number of floor into my floor population 100 into 3.8 is my nominal occupant flow, which is 3.8, which is given, and into the width of the staircase, width of the stair flight basically 1.7 plus 15 seconds, which is the time required for walking between adjacent floors. So, that is also given, which comes out to be 790 seconds, which is 13.2 minutes. So, for a 50-story building which is very high, very tall, 50 story means each story is say 3.5 meters. So, you are taking this much of time to come from the top to the bottom, if you are considered at the 50th floor. What will be Tn? That is, if you are straight walking down, no one is there. So, it will be 100, that is capital N, divided by the Fs by into W. So, you see 100 divided by 3.8, that is the nominal flow, into width of the staircase plus if you are coming down 50 floors at each taking 15 seconds of time, this is the total second, that is 765 second. So, you see when so many people are also coming down, you are taking around 13.2 minutes. If no one is there, even then you are taking 13 minutes. Why? Because your building height is very high. Also, see, I have reworked the whole thing with the population as 50. What is happening? The same thing will happen, only this will reduce by a small amount because this population is only at this point 50, whereas because you are rushing with the other people, you are coming down with the other people and there is 50, the population has reduced half times, your coming down time has reduced to 6.7, but this is not actual because your speed is included here. So, whichever is more you have to take that, whichever is more you have to take that. So, because this is 50, this is low, this is giving you a false information, because if you are coming down without any hindrance also, any people in the flight, you are taking around 13 minutes time, which is very close to this, because with this is independent of this 150, almost independent. So, you are getting a very small change, whereas here you see these are because of the crowding, it is giving you a higher time. So, we are supposed to consider this one for 100 population, we are supposed to consider 13 minutes for when it is even empty. So, what do you find through this small exercise? Higher the building, because 50 has a big contribution, higher the building, your time taken to come down walking becomes very crucial, because you have to traverse all the floors at your given speed. So, that brings in whether lifts can be allowed or not, because every building which is a general building having 3 floors, 4 floors, shopping malls of 3-4 floors, we always say no to lifts, because walking will be easier, because for lifts you have to wait, the lift has to come, and other than that the lift is the connector between the 2 floors. Smoke can enter into the lift, many things can happen. First and foremost, the power of the building will be off. So, the lift will not operate, because lift without electricity is of no use. So, staircase is only the area through which people can come out, is only the vertical movement option when the buildings are of lower heights. But when the buildings are getting higher and higher in today's context of urbanization, NBC now includes the fire lift also. So, what we see, egress time increases. If you can plot certain data, you will find that egress time linearly increases because of number of floor, it increases linearly because of the populations to be evacuated per floor, which is the occupancy load. So, evacuation time by lifts becomes shorter for office buildings with 15 floors or more, depending on the number of people moving from floor to floor. In a typical residential building, we do not encourage elevators. We usually recommend elevators, because in their case rescue operation within the stipulated time under an emergency situation becomes important, and the fire lift becomes important during such buildings, for such buildings. So, you see lift for movement during fire normally it is not considered, power supply gets disconnected, lift shaft runs continuous between floors and it forms a duct to be the carrier of smoke. However, evacuating by stair takes excessively long time, speed becomes low as the staircase becomes increasingly crowded, people become fatigued, as one is they are terrorized because of the fire most, and then the speed gradually decreases because of the crowding and because of they become fatigued or they become tired. So, lifts are required for evacuation when building has 15 or more floors in height. What would be the characteristic of such lift? We call this as a fire lift. It has to be under a certain pressure so that no smoke infiltrates. This lift should be enclosed within a lobby space where all walls or the all periphery should be having a fire rating, and as I have discussed on pressurization, these lobbies should be pressurized so that no, in case of opening of the door, no smoke can enter into it. Jamming of the elevator doors can happen, and it should have a separate lobby which is for the safety operations. Also from this fire lobby, from this lift lobby, fire lift lobby, you must have access to the fire hose reel. The firemen should be capable of entering into this particular area. Also, these lifts come against extra cost because they must be dually power supplied, because they must have an emergency power supply, they must also have the regular power supply. So, dual power supply is essential. Electrical systems are to be water protected because from here the hose reels can be charged with water and there may be lot of water spillage in and around. So, the electrical system should be water protected and there should be appropriate drainage draining out of water whichever will be accumulating in this particular lobby, they should be taken out immediately. The lift car should be under pressure. So, there we need special lift against special or extra cost. Area has to be sacrificed in each floor for creating such lobby space. So, you lose some amount of FAR for this purpose, and also backup generator supply should be there for such kind of lifts, because even if it is an emergency, the emergency goes, it should be connected with a generator system, so that this particular lift particular lift lobby and the entire fire lift assemblage should be connected with power. So, NBC has given this kind of a typical firefighting shaft or the fire tower, which is integrated with a staircase, with a lift and the lobby which I am talking about, plus the fireman's talkback system, so that the fireman can talk with his with the ground people. Wet riser hose reel or the dry riser hose reel should be here depending on the height of the building. Usually it will be wet riser because it is beyond 15 meters where wet riser is expected, and also you get the signage here, which is also mandated that every floor plan should be displayed at this particular point. So, this is the floor plan and stairway marking sign duly displayed. So, these are mandated for this particular fireman's lift or the firefighting lift shaft or the fire tower, which is taken from the National Building Code. So, here comes the fire safety concept tree, which is talking about fire safety strategies. First is prevent the ignition. If you can do it, it stops there. If you could not, you manage the fire impact. Try to manage it by controlling the fuel, suppress the fire, control by construction, that is passive methods. If you are managing the fire impact, it is one tree. If you could not manage, the manage exposed persons, manage exposed person and property. So, if you are not dealing with the fire is growing, you now try to defend in place and move out the people from there. So, cause the movement to happen, provide route for movement. In the managed fire case, what we were doing, we were controlling the fuel, or we were suppressing the fire, or we were controlling by construction. So, as I talked about compartmentation. So, from the controlling of the fuel, controlling the immediate areas, that is the lining materials, and construction, control by construction, you see here, control fire movement, provide structural stability. Control fire movement is to contain the fire and vent out the smoke. To suppress the fire, we have the fire systems which was discussed in the previous module, which is automatic or manual. So, automatically the alarm can ring, manually you can spread the news that there is a fire, and the entire fire safety concept should be imbibed in one's mind, that my rescue is, my step is not only saving myself, but also as much people I can address, my building structure should address, my suppression system should address. So, we can actually then take care of all the occupants, also my building also can control the fire, and we can remain safe. With this, I would like to end this module, and we will see you later in module 7. Thank you.